Dear students, firstly I will introduce myself, Professor S.H. Chaube, working as assistant professor in electrical engineering department of S&D College of Engineering and Research Center, Yeola. As we have seen the high voltage engineering, so now we have come to the point of the unit of the generation of high voltages and current. It means what are different methods we can generate high voltages and high currents. So you know that in the first lecture when we have seen the cascade transformer and in the second case the resonant transformer. At this time, what we have seen that not a single transformer is economical or not accessible to manufacture for the voltages above suppose that 400 kV and 700 kV. So for suppose we have to generate voltages more than 400 kV and 700 kV, then what to do? Then at this time, the solution is nothing but there is going to be different methods are given, that is a cascade transformer, resonant transformer. And in this lecture, we will see the next one, that is going to be Tesla coil. Tesla coil is also going to be used in this case. What is the main parts of that one? There is a voltage transformer, spark gap, capacitance that is going to be used, and the toroid on the secondary side of the where the high voltage is going to be generated. See here the simple diagram. Here AC supply is given, here AC source. Here is the high voltage transformer. Here is spark gap. Here is high voltage capacitor. Here remember that this primary coil will give you the value of L1 is denoted by value L1. This is denoted by value L2. It means that the output voltage which is produced is nothing but the function of L1, L2, C1, C2, C3 and the mutual inductance M. By this, all these parameters, you can calculate the value of the voltage generated at the output. So step by step, we will see what will happen for this case. It may be possible that if you can give AC supply or DC supply to the primary winding, to the capacitor. It may be possible that you can give either AC or DC to the capacitor C here through either capacitor and either spark gap. When what happened? Suppose a spark gap is triggered at a desired voltage V1. Suppose that the voltage coming on from this side, high voltage transformer is triggered, which induces a high self excitation in the second. Here is the second. High excitation is produced in the second. Both the windings are to the frequency of both the windings. Remember, primary and secondary are tuned to a frequency of 10 to 10 kilohertz by means of capacitance C1 and C2. See here, the capacitance is given. C2 is going to be also put up on this side. Where? Here. Here, remember, it is not given in the diagram, but this is a C1 and it is given into the C2. That can be used to generate or to produce the frequency of 10 to 10 kilohertz. So I just told you that the output voltage V2 is nothing but the function of L1, L2, C3, C4 or C whatever it may be and the mutual inductance. So now we will see the different, what is the basic principle. Remember that. Why it is called a Tesla? Why? Because it is going to be invented by a scientist Nikola Tesla in the year 1891. It is used to produce high voltage, low current, high frequency alternating current electricity. Remember, it is used to produce high voltage, low current, high frequency alternating current. Tesla experimented with number of different configurations consisting of 2 or sometimes 3 coupled resonant electric circuits. Now, the function is going like why we are going to generate, where is the use of these Tesla coils? This Tesla coils is vastly used in the different fields. Tesla coil has a very application, is very applicable to different fields. Just like to remember, Kepler used this circuit to conduct innovative experiment in electrical lightning, phosphorescence, X-ray generation, high-frequency alternating current phenomena, electrotherapy, and the transmission of the electrical energy without wires. Tesla coil circuits were used commercially in spark gap radio transmitter for the wireless telegraphy until the year 1920. And in the medical equipment such as electrotherapy and violet ray devices, this Tesla coil is widely used. Nowadays, the main use of this one for the entertainment and educational display. Nowadays, we can say nowadays, it may be used for the entertainment and educational display. Although small coils are still used as a leak detector for a high vacuum system. Now, we will see in detail, or in short, what is a Tesla coil? Tesla coil is nothing but a radio frequency oscillator that drives an air core double tuned resonant transformer to produce high voltages at low current. What we are going to use? We have to drive an air core double tuned resonant transformer to produce high voltage at a low current. Tesla's original circuit as well as most modern coils use a simple spark gap to excite oscillation in the tuned transformer. More sophisticated design use transistor or thyristor switches or vacuum tube electronic oscillators to drive the resonant transformer. But remember that what we are going to use to why we are going to study Tesla coil? Because we have to generate or we have to produce the high voltages. So by Tesla coil, you can produce or you can generate, you can create the voltages of 50 kilovolt to several million volt by large coils. It will depending upon the size of the coils. Small size, just we have seen applications. Small coils are where sometimes large coils are going to be used. The alternating current output is in low radio frequency range, usually between 50 kilohertz and 1 megahertz. Although some oscillator-driven coils generate a continuous alternating current, most Tesla coils have a pulse output. The high voltage consists of a rapid string of pulses of a radio frequency alternating current. What is it? Most Tesla coils have a pulse output, in the form of the pulse. The high voltage consists of rapid string of pulses of radio frequency alternating current. Now we have seen the diagram of the Tesla coil. Yes, first page was what? That is the diagram. So what are the components? What different components that is going to be used for that one we have seen. That first one, the high voltage supply transformer to step up the AC mains voltage to high enough voltage to jam the spark gap. I have told it. Once triggered in the spark gap, your work is complete. What is the main function? To trigger the spark gap. That is when the typical voltages are between 5 and 30 kilovolt. A capacitor C1 that forms a tuned circuit with the primary winding L1 of the Tesla transformer. What I have told when shown the diagram, just remember that this is L1 and this is L2. We are considering because the coil, you know that primary winding coils have a higher inductance as compared to the other factors. So this is considered as a L1 and this is considered as a L2. Over air L1, L2, in overcore double tuned resonant transformer will generate the high output voltage. Now what is my aim? Why I am going to study this chapter? Why I am going to study the high voltage engineering? Because my aim is actually to see how the high voltage can be generated in the case of high voltage. And this is especially for the generation of the high voltages in the high current. Optionally, a capacitive electrode E in the form of smooth metal sphere or torus attached to the secondary terminal of the coil. Its large surface area suppresses premature air breakdown and arc discharges, increasing the quality factor and the output voltage. You know the quality factor in the last lecture when we have studied the resonance circuit, then I have told you that what is the quality factor. If the quality factor 50, it means the output voltage is 50 times greater than the input voltage. Its value is given by 1 by omega CR. Right? So this is going to be about the Tesla coil of that one. So in the next lecture, we will see the high voltage DC generator. Till now, what we have seen the three methods. This is for the high voltage AC generator, AC voltage generator. Now, up to now, what we are coming? We are coming to the point of the generation of high DC voltages. It means how the high DC voltage can be generated.